I recently saw this cool chart from the Pew Research Center. It shows you the survey results of how Americans feel about businesses giving their customers suggestions about how much to tip. Basically, this chart is what is known as a diverging bar chart, and today I'm going to show you how to create this exact chart in ggplot. It's actually quite a lot of work to get all of the details right, but this is what we're going to do, so let's dive in. I've already set up a code chunk in my Quarto file that takes all of the data from the visualization. Basically, all of this part here is just something I typed out from the chart. You see in the chart you can see all of these numbers or infer the other numbers that are not explicitly shown. So I did a little bit of math in my head and I figured out the numbers. And it turns out that I only miscalculated a couple of times, but thankfully I caught those mistakes because the numbers didn't match the original image. So anyways, that's how you can easily get the data. You just have to type it out in this case. Actually, you don't even have to type it out because all of the things that you see in this video are already on my blog. So if you just want to get the code chunk with the data here, head to my blog, link is in the description, and then you're good to go. So the first thing that we need to do here is to rearrange the data because right now this data isn't in a good format for ggplot. So let's rearrange this with pivot longer. So let's take our data set and pass it to pivot longer. And then we target all of the columns between strongly opposed and no experience. So it starts with this column here, and then it goes all the way to the last column. And from there, all of the values go to the column percentage and the names go to the column called preference. And with that, you have a nice tidy format. So let's save this into a new variable. And for the diverging bar plot, we actually only need the first 4 preferences because the categories neither and no experience, they are in separate bar charts. So we can worry about them separately. First, let's just focus on the data for the first 4 preferences. So let's create a new data set where we just take our rearranged data and then filter it so that it only has the preferences that we are interested in. And that way we have only 4 preferences per label. Next, we have to do a little bit of math. In a diverging bar chart, we have a vertical line at 0 and the bars that go to one direction go to the left and the other ones go to the right. So we have a middle ground at 0. So this means if we stack up all of the bars, all of the numbers from one label, we will not get the right results because we won't have a common 0 line. So this is why for each of the labels, basically for each row with bars, we have to figure out what's the sum of the values in the opposing category, and this one will be the amount that we have to shift the stacked bars. So let's do all of that calculation in a new code chunk, and in there we take our data for the diverging bar charts and pass it to mutate, where we compute this middle shift, which is just the sum of the percentage column, where we only take the first 2 components. And in order for this to work, we have to make sure that this is a grouped calculation by label. And with that, we get an error because I forgot a comma here. But once we fix that, we can see that we get a new column here. And the value in this column always corresponds to the sum of the opposing categories. You see 18 plus 22 is 40. That's some quick math right there. And the same is true with all the other things here. And now what we need to do is to compute the x coordinates for the left and right edges of each bar. For that, we can compute a new helper variable, which is called lag percentages in my case, and it is just the percentage column shifted by 1. You can see here the values that are here come from there, but the one that cannot be shifted is set to 0. This helps us because the left edge is just the accumulated sum of these lag percentages minus the middle shift. If we execute this, we can't see a thing, so let me just make this larger here so that we can see a new column. Then we can see here that the left edge of the strongly opposed column is at -40, which is right because this is the middle shift. And then the left shift of the somewhat opposed category should be -40, this part here, plus the 22. And this is exactly what we get here. And the left edge of the next bar, somewhat favor, should be at the 0 baseline, right? Because this one is then at the other side. And this is exactly true here as well. And this is how you can work through these calculations to understand what's going on. I know this is a little bit tedious, but that's just what it is. Sometimes you have to actually do a little bit of calculating stuff. And by the same logic, we can compute the right edge. This one is the cumulated sum of the percentage and not of the lag percentages minus the middle shift. And finally, the middle points of each bar is just the average of the left and right edge. So left plus right divided by 2. And with that, we have a data set that has all kinds of computed variables inside of it, but these are really helpful for our bar chart. So let's save this into a new variable. And if you've made it this far, congrats, you have made it through a hard part in creating diverging bar charts. Oh, and this reminds me, there's actually another variable that we're missing. We also need to compute the width by computing right minus left. And now we have everything we need. Now we can come up with some width for our bars that we want to have in our bar chart. And then we take our data set, pass it to ggplot, and then we use the GM tile layer where we can use inside of the aesthetics all of the variables that we've just computed. Specifically, we need to specify the middle points of the rectangles that form the bar charts. For the x coordinate, this is just the middle point. For the y coordinate, this is the label. And then we need to specify how wide each rectangle is. And with that, we get a bar chart that doesn't really look nice because we don't have any color in it. So let's map the fill aesthetic to the preference column. And now we can already start to see that we have a common vertical line at 0 here. So our calculations actually worked. And right now the bars are quite big. So let's set the height to our variable that we call bar width, but really we stick it into the height. It's because everything is flipped around because everything is on the y-axis now. We could have used a better variable name, but let's just stick with it for now. One thing that we should rather take care of is the fact that the bars are ordered completely wrong. Right now they are sorted alphabetically, I think. Yeah, it looks alphabetically. In any case, this is not the order that we have inside of the original chart. So that's why we need to make the variable that we pass to the y-axis into a factor variable so that we can determine the order via the levels of that factor variable. Plus, we can take our computed values data set and modify our label column. And in there, we use the factor function to make the labels that we currently have into a factor variable. And we need to set the levels to what we have seen in the original data set. Because here, by the way, I have created this data set. We know that everything in the labels column is in the correct order because I've collected this data just top to bottom, just wrote down everything. So inside of this vector, the order is the order that we actually want. And by using this vector inside of our levels argument of the factors function, we make sure that everything is formatted nicely. But we actually need to reverse everything because on the y-axis, the larger values, the later categories will come at the top, and we need to have it the other way around. So that's why this part is in here. And then we save this into a new variable and we can replace our variable here. And then everything is in the order that we need. Again, this FCT reverse here was necessary, otherwise it will be reversed on the y-axis. You see, totals is the first level, man is the second level, woman the third, and the way y-axes work is that it's 1, 2, 3, and so on, and we want to have it the other way around, so we just reverse the levels in the factor, and then everything works nicely. Sweet, we are making progress, but we are far from done. Now we have to split up the bars here into the groups. Remember that in our data set, we have a column that is grouped, and in there we know that some of these bars here are grouped together. The total is alone, the genders, men and women, are grouped together, the ages are grouped together, the academic background is grouped together, and so on. So this is why we add a facet wrap layer and simply throw in the vars group function to create facets by this group column. And then we specify that we want to have one column and we want to make sure that the y-axis scales are 3. This means not every facet needs to have all of these labels that we currently see, but only those that are in the group. And if we execute this now, we get sort of the correct thing. We have split this into windows now, and each of the groups only has the things that are inside of the group on the y-axis. That's because this part here is there. If I remove it, then every window would have every group. That's not what we want, but still, this image isn't quite right, because the bar charts are of different width. And the reason why this is happening is because every group for which we create a window has a different amount of members inside of that group. And the width of the bars are chosen so that they fill the whole space, but that's not really what we need here. Luckily, there is an easy way around that. At first I thought this was really complicated, but actually it's quite doable. We just have to replace facet wrap with facet grid. And then we specify that the rows are mapped like this. And in that case, we don't need to specify how many columns we want. And then we get something like this. This doesn't look that much different. Actually, it is kind of the same, but facet grid has one more argument that we can use. And this argument is the space argument, where we can specify that the y-axis space is also free. And now everything gets space according to how many members are inside of a group. And that way we have bars that all have the same width, which is really important for this chart here. That's great. Now we have to worry about the order of the windows. You see, the windows are not ordered in the way we want. We want to have the totals at the top, then we want to have the genders, then I think it was the ages and so on. But luckily we already know that trick. We just have to modify what we map here. In this case, it's the group column. We just have to make this into a factor variable and specify the levels accordingly. So let's do that and create a new data set. Let's call this dataset sorted group stat. That way we know that in this dataset everything is sorted according to how we want. And then we have to use our factor that dataset and mutate the group column. And there we use the factor function again to set the levels. And once we have done that, we can just replace the dataset. And now our windows are in the correct order. So right now the basic diverging bar chart is done. What we have to do now is to apply a lot of theming. And because this theming involves all kinds of text sizes, plot sizes, and so on, we should probably make sure that everything we see in the window here is final. And this is why we're going to set a camcorder. So let's throw in a code chunk in between here. And in there we can set the camcorder. So we're calling ggrecord from the camcorder package, and then we set the directory with height and the unit of our image. And now if we execute this, all of our plots will immediately be rendered as an image and displayed in the viewer window. And that way the sizes do not change when we make this image larger here. So even if I make this very small, we can see that everything still is legible and there's not a lot of overlapping text. Okay, so this is one of the things that can be really tedious with ggplot, but we have fixed that by just using the camcorder. So now we can apply the first batch of basic theme changes. Let's go over them quickly because we have a lot of other stuff to do as well. So we use theme minimal where we set the base size and the base font family. And we use the theme layer to get rid of the legend. We'll get rid of the labels of the facets. We'll remove the axis titles. And we can get rid of the grid lines because we don't need them. And finally, we also don't need text for the x-axis. This is looking pretty good. Now let's make sure that the colors are right. Let me just throw in a couple of colors. I use this color palette vector with names and colors here so that we know the correct colors for each of the categories that we have. And I've also specified the gray color here. These colors are something that I've just extracted from the original image. You can use your web browser or some color picker or whatever tool you like. The point is you just need to figure out how to get these hex codes. And once you have them, you can throw them into a vector. Again, all of this code is on my blog, so you don't have to figure out these colors yourself if you just want to use the one that I picked. In any case, what we can do now that we have a colors vector is we can add a scale fill manual layer and use the color palette vector as our values. And with that, we have nice colors for our chart. And it really is surprising how much better it already looks once you have good colors. I don't know, maybe it's just me, but with the colors that we had before, it still looked very rough. But the moment I throw in a nice color palette, everything looks much smoother. But enough raving about nice colors, now let's do the hard work. We have to get in the labels for our charts. In the original image, we have labels on the left and right of each bar, and we also have labels for the strongly opposed or strongly favored groups. The way to get those labels inside of the chart is always the same. You use a GM text layer, filter the data so that that text layer uses only the data for the part that you want to add. And then you have multiple GM text layers for each part that you want to throw in there. Let me show you how that works. Let's throw in a GM text layer below the GM tile layer. So as I said, we're using a GM text layer and we need to modify the data that is in there. Right now, this would use the complete data set. But what I want to do is filter this data set so that we only have the things that contain strongly. So this means that we only have strongly oppose or strongly favor. We can do that with a filter call and using string detect. And that way we get exactly the right data set. And then we can specify the aesthetics for this specific layer. In the case of the strongly oppose or strongly favor groups, we have to put in the label in the middle of the bar. So this is why for the X aesthetic, we use the middle point column. You know, the one that we computed here. And then on the y-axis, we use the label. And as the label, we use the percentage. And when we execute this, we get something like this. And then we can modify things like the size and the color. Here, I want to make sure that the colors are different because this bluish color is kind of dark. So it would be nice to have a white label there. So that's why I assemble a color vector using the repeat function. And this way, this is nothing but a vector that always repeats white, this hex code, white, this hex code, and so on. And if I put this in there, you can see that all of these labels became white. Next, we use a nice font family and we make everything bold. And now we can do a very similar thing with the labels that are on the left and on the right of these bars. Let's start out with a new GM text layer. In this case, our GM text layer will have to use a dataset that filters for strongly oppose. And then we can set the aesthetics again. Now the X coordinate should be the left edge. The Y aesthetic should still be the label. And then for the label, we have to be a little bit more specific because the label that is at the top has net number and the others just have some number in it. So that's why we assemble these vectors using the paste function to assemble the vectors so that only the first entry starts with net and all the others just start with a blank text and are followed by the number that should go there. But since the things that are in the left column are always negative because it's the left edge, we have to make sure that we use the absolute value in here, and then we get a chart that looks like this. That's actually already pretty good. We have our labels almost where they are supposed to be. Let's change the size, change the color, let's change the font family and make this bold. And now we have to make this right aligned. And by choosing a value larger than 1, we actually shift this even further to the left. And finally, we have to repeat the same steps for the right edge. So we use strongly favor here. We use right here. We use right here as well. And for the justification, we need to make sure that everything is left aligned. So we have to use 0 there. But we should also go a little bit lower than 0. Let's do -0.1. That way we have a kind of symmetry for the left and right labels here. Oof, this was quite a lot to do. I know this is tedious. Adding these labels is always painful. We still have a couple of more painful things to do. But first, let us throw in the vertical line because this part is easy once you know the trick. You see, normally what I would do to get a vertical line is to just throw in a GMV line layer. But if I do that, then I get one vertical line for each window of my facets. You can see here that there is always a gap between those two lines. And that's annoying. We want to have one line that goes through all of the facets, through all of the bars. At first this was driving me crazy because I thought we had to do some very elaborate thing, but then I found a nice community post that I will put onto my blog. You can find a link to that post there, and it shows you an easy trick how to avoid doing fancy stuff. You see, all you have to do is to minimize the space between the windows, and then it will look as if it is one line that goes all the way through. So let's do that. Let us set the panel spacing to 0, and that way things are together quite nicely. But now there's only so little space between the groups and I want more. So this is why we have to modify the expansion of the y-axis, and once we make that larger, the spacing between the groups will be larger. So that is why we throw in a scale y discrete and put in some extra spacing for the axis expansion. And that way you have more room between the groups. Quite nice trick, isn't it? Again, I'm thankful for the nice community post. Link to that is in the blog. So this was a nice win. Let's tackle another easy win, and then we work on the hardest part of this image. But let's not get ahead of ourselves. Let's do the easy thing first. What I want to do is to add the labels for the colors here. So I want to put in labels that say strongly oppose, somewhat favor, and somewhat oppose. And as always, the way to do that is to throw in another GM text layer. So let's add one to this chart. Let's throw in GM text. And then we have to think about what data we want to use. Just like we filtered the data here, we have to do the exact same thing, because when we put in the labels with the whole data set or even with an annotation, it will put all of this in each and every window of our facets. But we only want to have this annotation at the top. So this is why we need to make sure that our data has only the data for the total group in there. So let's set group to total. And then we can specify the aesthetics like we normally would. On the x-axis, we'll use the middle point column. On the y-axis, we'll use the labels. As the labels, we'll use the preference because this is what we want to let the label show. And for the color, we use preference as well. And now if we execute this, we get labels that are in the wrong position because we need to nudge it up a little bit. And they also have the wrong colors. And they also, I'm not sure if you can see it, they also use somewhat_oppose. They use variable names, so we need to translate all of this. Unfortunately, we cannot just move up the labels because the labels right now are discrete. So if I put in +2, say, then I will get an arrow because this plus says it's not meaningful for factors and I will get an NA here. So that's why instead we have to use the nudge y argument and use a number like 2.5 in there. Now the labels are cut off, so let's modify them a little bit. Let's change the size, let's change the font family, let's make them bold, and most importantly, let's top align them so that they move down. Next, we have to figure out how to change the colors. Well, that part is easy. We just have to repeat the scale fill manual, but use this for color. And then we get the correct colors. But we're still not done with this part yet, because we still use this strongly underscore oppose and somewhat underscore oppose and so on here. The easiest way to fix that is to basically place a dictionary inside of your code chunk. So we create a vector that is named. So for each of those things that we have right now, we have a translation of what it should show. So here it is somewhat line break. This \n is a line break, and then it says oppose. And the same thing happens for all of the other labels. And with this vector, we can now modify the labels here. Let's scroll down all the way until we are at the right GM text layer. And in there, we can just use the vector like this. And then we don't get the right result because I have actually put this into color and not label. So let's put this in here. And now we get the right result. But the line break is actually quite large. So let's change the line height and set it to something like 0.8. This looks much better now. Whew, this is exhausting. Are you still with me? I know this is a lot of work, but we will get a nice chart at the end of this. So it's all worth it. We just have to keep going. But one thing we should do before we move on with the labels is to move the labels a little bit. You see in the original, the labels strongly opposed, somewhat opposed. They are not exactly over the middle of the bars. So let's shift them a little bit. Let's do this like this. Basically, for each of those labels, I have decided how to shift them one by one. And I added this to the x coordinates that we've had before. And now comes the hard part. Now we have to draw a pointer from each of those labels to the middle of each bar. And because the original has this zigzag pointer, we need to use a step function to make this happen. The layer for that is gm step. So let's put this in here. But now the question becomes, what do we put in there? To make the pointer, we need 4 points for each label. That's the only way to get the zigzag. So let's create a data set that basically takes this data and repeats the data. So let's throw this in here. Let's align this. And then we can also throw in the middle point variable that we have computed earlier. So this way we know that the middle point variable that is in here corresponds to the middle points that we have set for the labels, basically the shifted labels. And now we throw all of this to bind rows where we don't modify the labels. So basically for each of those labels, we have 2 coordinates now that are encoded in the middle point. That's why we call this pointer data. And now because we need 4 points to get the zigzag, let's just repeat the pointer data by using the bind rows function. So we just have to throw in pointer data twice in there. And let's call this double pointer data. And if we execute all of this, we have 2 new data sets at our disposal that we can use for this step function. And to make sure that we know how things are sorted in this data set, let's put this on a new line. We're also going to arrange this by the middle point. That way we can be sure that the rows that come here are always first the smaller x coordinates and then the larger ones. And this will also be the order that the step function uses. So that is why it was important to arrange everything so that we know what the order in this data set is. And now if we go back to our step function that we have left empty, we can fill this now with our new data. So we use our new double pointer data, and in the aesthetics for the x-axis we use the middle point column. On the y-axis we use the label. And since we want to have one step function for each of those labels, we have to use the group aesthetic. And if we execute this, we can see that we have one line for each of those points. We can even modify them by setting the line width and the color. This way they get a little bit thinner, but they are still in the wrong position. Once again, because the y aesthetic is not a numeric variable, but instead a discrete label like total, man and woman, we can't just add +2 to shift everything up. What we need to do is to use the position argument and use position nudge. And there we could shift everything up by 2. And if you put in the comma there, you can see that everything moves. Let's maybe just use 1. Now the line is in the middle. But the problem is this doesn't look like a step function now because everything is on the same y coordinate. And the only way to fix that is inside of position nudge is to use different nudge amounts for all of the points that we have. So that's why instead of a constant, we need to use a vector here. So let's move up to create this vector. And I'm just going to throw in the code here. Basically, this nudge vector is this vector here, just some numbers that I've chosen. Basically, the one nudge value that I found was too large. The one that is right at the top of the bar, you see if we have bar width divided by 2, you shift from the middle point of the bar to the top edge of the bar. And these two values are the middle points between the value I liked and the upper edge of each bar. And if you have that, you get 4x coordinates, but you need this part multiple times because you need this part for each of those labels. But the problem is that for the favor and the oppose categories, things need to be in the opposite order. So this is why what is at the top here is at the bottom there. So this is how you assemble such a vector that shifts each point separately. And if you use this vector inside of your position nudge, then you get actually this zigzag line. And again, this weird way why we had to come up or construct such a weird vector is because the y aesthetic isn't a numeric variable, so we can't just add everything, and we have to shift each point separately. And the order in which we shift points need to be different, because if you look from left to right, for the oppose category, it is first a stronger shift that you need, and then a smaller shift. And for the favor categories, it needs to be the other way around. So I hope this became clear. Now what we can do is to add a point layer to this that puts in the points for the pointers. At this point is the easier part. You have to use gmPoint. In the data argument, you get only the data that corresponds to the top window. And for the aesthetics, you use then the middle point and label again. And now you only need to nudge everything by a constant, namely by this bar width divided by 2. And then you set the size and the color of your points. And now you have the points for your pointers. And with that, we have finished the first part of our total chart, but this was actually the hardest part of all. So we have most of the video done. Really, congrats if you've made it this far. This was the hard part. Let's save all of this plot code into a variable. Let's call this diverging bar plot. And if we save it like this, then we have everything we need inside of this variable. And now we can worry about the other categories, neither favor nor oppose, and no experience. For the sake of time, I will just give you the code for these parts because they are really not that spectacular. If you can create a diverging bar chart, I don't want to bore you with the details of a simple bar chart that looks like this. Basically, we did the exact same thing as before. We sorted everything from the original data. We have to keep in mind that this data isn't the sorted one, and all of our values are now inside of one column. And then if we have sorted everything, we can pass this to gmcall. We can add the labels with gmtext again, and we have the same facet grid trick. But what we do have extra here is that we got rid of all of the excess text because we don't need any text here. We don't have any labels for the things that are on the y-axis because we will put all of the charts together, and then we have that from the diverging bar chart. Also, I kind of took a creative choice here and deviated from the original image because I felt like it would make more sense if the labels are at the top of the bars. In any case, that's the neither favor nor oppose chart. We can do the exact same thing for the no experience chart. So again, I'm just going to give you the code, and it's this simple bar chart here. So now we can put all of this together into one large plot using the 3 variables that we have: diverging bar plot, no experience chart, and no favor chart. I'm not 100% sure how I named this. I named this neither chart. That's the variable name. In any case, we can put all of this together using the patchwork package. In case you haven't worked with patchwork, it is a truly great package because you can assemble all of the plots you want in all kinds of patterns. If you have no clue what I'm talking about, you can check out this video here. It's where I take a deep dive into the patchwork package. But even if you haven't followed that video, you can still understand what's going on with patchwork. It's really not that hard. That's the beauty of patchwork. It's simple and elegant code to combine charts. In any case, all we have to do is load the patchwork package, and then we take all of our charts and add them together. This looks terrible, but one of the reasons why this looks really terrible is because we are in our plots window again. You see patchwork, whenever it is called, it deactivates the camcorder. So let's reactivate the camcorder so that we know that our sizes are good. And now if I re-execute this code chunk, then things look much better. But what I want to do right now is to make the diverging bar chart much larger than the other bar charts. So this is why I add a plot layout function, specify that I want to have 3 columns, and the widths are as follows. This way the first chart, this is the diverging bar chart, will be 3 times as large as the other 2 charts. But the way I've set this up is actually bad. I just wanted to point this out here because it's really easy to make this mistake and not notice it. Because what is wrong here is that these bar charts here are giving way too much room compared to these. Think about it, the numeric value here is 7 and the bar is this large. Compare this to this bar here, which is apparently a value of 22, you see that this cannot make sense. So this is why you need to make sure that your widths of the individual charts and the widths inside of the composition are chosen accordingly. So that's why for each chart we set the x-axis limits to something specific so that we know how large each chart is. So really what this means is that we take our original chart and throw a scale x continuous on there, set some limits and remove the expansion. And then we save this into a new variable and we do the exact same thing for all charts. Of course, the limits will be different depending on how the chart looks. But once you have those limits, just choose limits that look good for the individual charts. Once you have those, you know how many units basically each chart covers. The width of this bar chart covers 100 units now, and this chart here covers 45 units now, and same thing for this chart here. So it would make sense to use widths that reflect these limits here. So 100 units, you could set this to 100, you could set this to 45, and this one to 45 too. But of course you have to use the new variables. And then when you do this, you get a chart that looks like this, and you will realize that the height of this bar here now, this one looks actually much more like, for example, the 9 that we have here. So that way we know that the dimensions of the bars in each subplot are chosen wisely so that they all reflect the same amount of units. And by the way, in this vector here, you could also just use 1, 0.45 and 0.45. That's what I've done in the block. It's the same thing. As long as the ratios here are the same, it doesn't matter. I could divide this by 100 and then the image will still look the same. Oh boy, we are almost done. We are almost finished. We just have to throw in the labels like title, subtitle, and so on. And then we are finally done. We have completed our chart. So let's throw that in and then we can all do something else. I have the feeling that this video is already quite long. So let's create some variables for title, subtitle, and caption. I've just typed out what was written in the original image and put this into title, subtitle, caption, and so on. If I wanted to have line breaks, I have put in the \n operator to make line breaks happen. And now with Patchwork, it's really easy to throw this in as title, subtitle, and caption for the assembled chart. All you have to do is to throw in a plot layout function. In this plot layout function, you can then set title, subtitle, and caption, and you will get all of those things in there, but they use the default settings, which are obviously terrible. So this is why you can set the theme argument and in there use the theme function. And now, just like in a regular theme function, you can throw in all of the theme changes for the text and the text only. So let's throw in element text for plot title, for plot subtitle, and for plot caption. I believe at this point you don't want to see all of those details here. Point is, they make the chart look nice. Wow, we are almost done. There's just a tiny thing that is missing, and that is the Pew Research Center label. You see, all of their charts have this big bold Pew Research Center stamp on them. And in this chart, this label is below the caption, so we actually have to throw this in there. And here we can do a simple trick. We just modify our caption to put in Pew Research Center, but we use Markdown and HTML notation to change the font for this Pew Research Center only and leave all of this part as it is. So what this means is that I throw in this text here. I have to replace all line breaks with the HTML line break notation, which is this BR thingy here. And then when I want to add the Pew Research Center label, I can use Markdown notation to make it bold. And then I can use the span text to set the style of only this part here, where I set the color to black and the font size to 6 points. And afterwards, I did the exact same thing and put in a little label that I remade this with ggplot. And now in order for this to work, you can see if I execute this now, this just throws one long line. You actually have to make sure that you use markdown notation. So you have to set this to element markdown here. Everything else can stay as it is. Whoa, we have made it. We have created this beautiful chart all within ggplot. I don't know about you, but I think that's a pretty cool accomplishment. So pat yourself on the shoulder if you've made it this far. And if you like this video, then I am very certain that you will enjoy my data visualization course, where I show you how to do all kinds of data visualization principles with R. And more importantly, I have a lot more long form videos like this in the course that show you how to create elaborate tables to communicate insights effectively. Check that out, link is in the description. Thank you for watching, and I will see you in the next video.